Okay, today we're going to be looking at what are called box and whisker plots. So just another way to kind of show data in a more visual way. And these are a little weird at first, but they're actually very helpful. They kind of show you how data is clustered. That's their main focus. Show you where, if there's a big group of numbers that represent something, say test averages or something like that, they'll show you where most of the kids' test grades are, and when kind of show you where there's a couple but not as many. So when they say clustered, and if you go down here, they say data clusters, it's where there's a whole bunch. So if we all took a test and a couple people got 100, a couple people failed, and then you had some people in the 70s, but then you had most of the class in the 80s, this kind of graph would show you that cluster, that data cluster, where, oh, a lot of the class is right there in the 80s. So that's where this is really helpful. It kind of shows you how spread out and kind of where the data mostly falls and where it doesn't. All right, so when we look at this, you're going to have 4 dots, and what they're doing is they're splitting the data into 4 pieces. So this is going to be your middle right here, and we discussed yesterday the middle is the median, okay, and then these dots all the way on the end, they represent the lowest number and the biggest number, and those are called your extremes. So this is your lower extreme, and then this therefore is your upper extreme. So what does the extreme tell you? It tells you the least number of days it rained or snowed, because that's what this graph is talking about, in a month. So the 2 down here, that's the least number of days that it snowed in a month. And then up here, it's the greatest number. So if we had a whole list of numbers here that represent the days that it rained in a month, okay, there's this one up here that was 10, there's this one down here that was 2, and then most of it was in the middle. Most of the months fell somewhere in the middle in terms of the days that it rained or snowed. Now the median tells you half the months are below this and half the months are above it. So in this specific graph, the 6 represents the days that it had rain or snow. So half the months had less than 6, and half the months had more than 6 inches of rain or snow. So this is the split. This is the middle one. All right, and then you've got these 2 other splits, which again are cutting this into 4 equal pieces. You might say those don't look equal, and we'll talk about that. But if we had a list of data, the same amount of numbers fall in here, and here, and here, and here. In fact, this cuts this up into 25%. So if there was, say, 100 numbers that we were putting on here, 25 would be in here, 25 would be in here, 25 here, 25 here. Now this one's bigger. That just means that, yeah, there's 25 numbers in here, but they go all the way from 3 to 6. They're spread out. Then there's 25 numbers that are between 6 and 7. Then there's 25 numbers that are in here. So these are all equal amounts of numbers, but that can still be more spread out or more clustered, like right here. There's 25% of the numbers right in between 6 and 7. So again, same amount of numbers in each one of these blocks, but some of them are more closely gathered in terms of what they represent. Alright, so we're going to use this box and whisker plot down here. So taking a look, this has something to do with baskets being made. So here's your median. That means half the data has less than 10 baskets being made, and half the data has more than 10. Lowest number is 5 and the highest number is 15. So right here, let's answer the question. What are the least and greatest number of baskets made? You go to the end, you go to the other end. So the answer to that is 5 and 15. So let's say this is a company and they're making baskets and they're just rating all the people that work there. And they're saying, how many baskets do you make in a day? Well, one person made 5, and one person made 15. And pretty much everybody else fell in the middle somewhere. So those are the extremes, the least and the greatest. But most of the data is in here. Now it says, what's the median number of baskets made? So you're going to have some people that do really, really well and make a lot. You're going to have some people who don't make as much. But what's the average? What do most people, if you kind of took everybody and put them together and had to come up with one number to represent it, what's the median? What's the middle of everybody? Okay, and that's going to be right here, and that's 10. Then what are the upper and lower quartiles? So going back up to this one, this is your lower quartile. And then, oops, that's your median. this other break up here at about 75%. That's your upper quartile. Because it's cutting up into quarters. So the median is your 50%, you're halfway. Then your 25% and your 75%, those are your quartiles. And then you got your extremes at 0 and 100 basically. So if we come down here, what are the quartiles here for this data? So your lower quartile is the edge of the box. That's 6. And then the spot where the data is cut in another fourth is up here. And that's 12. Now I'd ask, where is the data clustered? Where is the data clustered? So if you take a look, each one of these represents the same amount of numbers. So let's again go back and say that maybe there's 100 people that work here. Well, 25 of those people fall in this range. 25 fall in this range, 25 in here, and 25 in here. So when they say clustered, where are they most closely gathered? So if you look, there's 25 people between 5 and 6. The next 25 fall all the way between 6 and 10. So they're spread out. So they are definitely not clustered. This is not clustered. In here, they're pretty clustered. It goes from 10 to 12. So there's 25 people within 2. And then up here, it goes from 12 to 15. So there's 25% of the people in this 3 basket range. But where's it the most clustered? That would be right here, because there's 25 people all within 1. This one's close. There's 25 people within 2. Okay, but 25 people all within 1 basket. Okay, so 25 people either made 5 or 6 baskets, and then the rest all here are spread out. So this is what the clustered means. Where's the smallest region, basically, is what they're asking here. So the smallest region is from 5 to 6. And now it's just asking you to see if you understand what the extremes actually represent. So what do the extremes tell you about the number of baskets made? It tells you the least number of baskets made was 5. And the most was 15. So it tells you the least, and it tells you the most. All right, let's flip it over. So on this side now, we're going to actually make our own box and whisker plot. So step 1, and this will be good notes to keep, order the data from least to greatest. So I've got this data, but it's just in a random order right here. So I'm going to reorder it. So as I look at this, the smallest number is 27. Then there's a 28, and you may want to cross them out as you go. 28. There's a bunch of 29s. 1, 2, 3, 4. Okay, then there's a 30. 31. 33. And we're left with 35 and 38. Okay, so we ordered the data from least to greatest. We did that. Now we need to find the median. So remember, the median is your middle number. Now I don't want to cross these out because I'm going to need these numbers, but this is the kind of problem where you'd cross out the biggest and smallest, biggest and smallest. So let's just follow it in. Here's the biggest and smallest. Bring it into the next ones, the next ones, the next ones, the next ones, and you're left with one number in the middle. So one strategy is to cross them out, but I'm going to use these numbers throughout this page, so I don't want to cross them out. But I went to the middle, so 29 is my median. Now we got to find the quartiles. So what this is going to do is now you've got 2 separate little sets of data. 29 is the middle, and it's kind of isolated by itself. I've got this group of 5 numbers. I've got this group of 5 numbers. Here's 50%. We need to cut it into a 25% and a 25%. So what you're going to do is you're going to find the median of each half. and that's up here, to find the upper and lower quartiles, or the medians of each half. So I've got 5 numbers down here. Biggest and smallest would be 27, 29, 28, 29. Okay, the median of this bottom set is 29. And then the median of this top set, you got 30 and 38, you got these, is 33. What are the extremes? That would be the smallest number and the biggest number, so 27 and 38. So step 3, find the extremes. Now we're going to actually draw our box and whisker plot, and these are all the numbers that we needed to draw this. So let's draw the number line that begins with the least value and ends with the greatest value. So I need to start at 27, and this one's set up perfectly for you. Sometimes you're going to have to count by something other than 1, but here we're going to count by ones. 33, 34, 35, 6, 37, 38. So they made this graph perfect for you so that it goes from 27 to 38. Sometimes you're going to have to count by 5s or 10s or something else to make it work. Alright, so we drew the number line that has the values. Now we're going to plot a point at the median. So we need a point at 29. We need our upper and our lower quartiles. Now if you notice, our lower quartile and our median are the same number. So we just need 1 dot for both of those. Our lower extreme here is 27. Upper extreme is 38. You're just putting a dot on each spot. And then 33 was our upper quartile. So normally you have 5 dots, but we only have 4 because both the median and the lower quartile are 29. Okay, step 6, draw a box going from the lower quartile to the upper quartile. So from here to here. And then you always put a line on the median. So if the median was in the middle here, I'd put a line straight down. It was 30 or 31 or 32. In this case, the median's right here. Okay, so I don't have to put an extra line because it's already there. And then the last thing is you're going to draw a horizontal line that connects the extremes to the box. So usually, if we go back to the other side, if you flip it back over for a second, usually when you draw this, you've got your quartile, and then your median in the middle. Okay, in this case though, their median is right here, so this data is going to look a little different. Alright, so let's answer this question. In a box and whisker plot, what fraction of the data set is included in the box? What fraction of the data? So remember, on a normal one, that just looks like this, that's got the nice little median in it. I've got 25% here, 25% here, so 50% down here, 25% here, and 25% here. So it's asking me what fraction, and we can talk percents to fractions, is in the box. So what's in here? So you've got 25, 25, 25, 25. That's a quarter, a quarter, a quarter, a quarter. You've got half below the median. You've got half above the median. So you've got 25% here and 25% here. That's a total of 50% of the data. Oops. Which they're asking for a fraction. So that equals half the data. So half the data is inside the box. That's what it's asking. And then how much in the 2 whiskers? So each whisker is 25%. And that equals a fourth of the data. So you've got a fourth of the data here, a fourth of the data here, a fourth of the data here, and a fourth of the data here. Half and half. So you're just cutting the data into pieces so you can analyze each one. Alright, so today's work, you're going to practice looking at these and then also making these and making sure you can find the medians, the quartiles, the upper extremes, and interpret that data.